Wint, Watwood. Here in Missouri S&T, we are all about safety. That is why you are watching this video from home, and I will be out of a job by the end of the weekend. But let's talk about safety in the welding environment. PPE refers to personal protection equipment. In welding, there's a lot of PPE that you have to pay attention to, from your feet to your head. Starting with your feet. Leather boots are a must. You need them above the ankles, and your jeans have to go over them. And then you need blue jeans. And blue jeans or leather chaps. And here we will use blue jeans. But next, you're going to need a flame retardant jacket.
Stylish.
Even flame retardant will burn up over time and you will get holes in them. So make sure it's in good shape, and if you're going to be welding overhead, wear leather. As always, in any of the Missouri S&T labs, safety glasses. They are a must. In addition to safety glasses, a welding helmet. You want your welding helmet to have at least a lens, a shade 10 lens, for any of these procedures. Next, welding gloves.
Hey Wint, where can we find this equipment in the lab?
Welding helmets up there. Gloves out near Mike's office.
Yep.
And then
Right here.
we have a large selection of greens that work just fine.
Perfect.
Once you find all your gear, you put it on, you are ready to become a welder. Oxy-acetylene welding is going to be the first process that we talk about today. We will not actually be welding for y'all, but we'll talk through setting up the torch in a safe and responsible manner. So, first thing you want to do is make sure your valves are closed to the torch. And then, secondly, you want to start out by opening your fuel. When you open this fuel, you want to make sure that gauge is not facing anyone. Jake has moved out of the way to make this safe. All right. And you crack that open about one turn.
What could happen if it goes poorly?
If the person before you accidentally screwed it in all the way instead of screwing it out like you're supposed to, that pressure could put enough on that brass screw that it shoots out and lodges into your shoulder, or really it can lodge into anywhere on your body.
And we want to prevent that, so.
You don't want that.
Yes.
No, sir. Next, oxygen. And you're going to crack this open all the way.
See these dials?
A good setting for these is around 7 for your acetylene.
Around 7 on this gauge here.
And our oxygen looks set up just fine.
Those are kind of what you're looking for there.
All right. To start this torch, you want to crack that acetylene open very slightly. And it may not be enough, but you can use this spark lighter and slowly adjust that as to get a nice small flame. If you open it too much, you're going to have like a fireball. You want to keep this pointed away from you and other people.
Safety.
Fireball.
Yeah, don't do that.
So, when you're adjusting this acetylene, you go just until all that sudden smoke clears. Maybe y'all can see it in the video. And then crack your oxygen, and a cone will start forming. You go until that cone simmers into one small cone. You are ready to oxy-acetylene weld. In turning off, you first turn off your oxygen, then you turn off your fuel. Then you close your fuel, and then you bleed that line by cracking it open again. You'll see the gauges go down to 0 and no pressure in there. From there, back off until it is free and there's no pressure in the gauge on the screw in the gauge. Next, you close your oxygen. You perform the same procedure. You have just safely seen an oxy-acetylene torch be made to a flame and cut down.
Alright, so now we're going to talk about MIG welding. So for MIG welding, we've got two settings here. We've got the feed rate and the voltage. Yeah, this is the actual wire that will feed for MIG welding. So if you increase the feed rate, when you're welding, you're going to need a higher voltage in order to strike off that weld wire. So if you increase one, you're most likely going to have to increase the other. And it's kind of, you work with it as you go. So this is our ground that grounds the weld, and then we feed with this and you weld on your surface. So that's MIG welding.
So next we're going to talk about stick welding. Stick welding is the best welding. It's what we use for all structural stuff. It's been around for a long time. It's real convenient, and it produces very strong welds relative to MIG welding or oxy-acetylene welding like we've been talking today. So your average stick welder this is a classic. This is a Tombstone 225 Lincoln stick welder, and that's what you're going to see in just about any guy's garage shop that owns a welder more than 10 years old. That's a staple. That's what we're going to be using today. So we got two different types of electrodes. One is a 7018, it's a 1/4 inch thick, and then one is a 6013, which is 3/8 inch thick. And yeah, basically you just stick this electrode in the electrode holder. You clamp the ground onto the table, and then when you touch that, you get an electrical arc. I didn't turn this off, so put that down for PPE. So when you touch that, you're gonna start a current from this electrode to the table, and after that you can lift it off just a little bit and keep about an 1/8 inch of a gap off the table, and
About that
arc
much.
will just turn into like a little lightning strike and just melt this electrode down, melt the workpiece, and you got a nice clean weld beam.